So I'm going to tell you how we do the demo too. Hi people on the videotape, my name is Anders and this is the surface area nanotechnology demonstration. Hi guys. So, hi, my name is Anders.
Hi.
How you doing?
Hi.
So we're going to start off by looking at these wooden blocks. These are models of nanoparticles of silver. And these are models of germs. And the thing is that silver can kill germs, but it can only kill germs wherever it can stick to a germ. So you guys can stick some germs into some silver. And these are models of nanoparticles, and that means really, really tiny. It means they're 10 or 100 nanometers wide. And so a meter is about a yard long. A nanometer is a billionth of a meter. Meter, billionth of a meter. Your fingernails grow 1 nanometer every second. It's tiny. So these are really tiny. They've just got 100 atoms in them. Everything in the universe is made out of really tiny things we call atoms. Well, these just have 100 atoms or 1,000 atoms in them, which is not very many atoms. Good job. And so the thing is that what I want to teach you guys today is that when we make really tiny particles, all the atoms are on the outside and none are on the inside. They have a lot more surface area, and so they act differently. And so if we look at this big block versus cutting it up into little blocks, which way do you think will kill more germs?
This way.
The big block, you think the big block will kill more germs? Because the big block, I have my germ counter here, it's got 6 sides with 4 germs on each side. So that will kill 24 germs. That is big. So this is 24 germs right here. Each little block has 6 sides. So it'll kill 6 germs. But we have 8 little blocks when we cut up the big block. And so it'll kill twice as many germs, because all the silver's on the outside. This big block here, you can even see because of the way we painted it, all the inside that's stuck inside the block. So there's all this inside, and if we take the blocks apart, you can see all the inside that's trapped inside and not able to kill the germs. And so the big block has 6 sides, 9 squares on every side, so it'll kill 54 germs. 54 germs looks like this many. But if we cut that big block,
What about this one?
so I'll get to that in just a second.
That would be that'd be like 100, 200, 300, 400 probably.
So that's 1,000.
Yeah.
So if we cut the big block into 27 little pieces, all its little pieces, it'll kill this many germs.
Whoa.
27 times 6, 162. A lot more germs. And so then this little block shows what would happen, sort of, if we cut just one of those little blocks into 1,000 little germs. 1,000 little pieces. It would kill 1,000 times more germs. And so we don't need a big thing of silver, we just need little tiny nanoparticles of silver, like the ones in these socks. These socks have little tiny nanoparticles of silver that'll kill germs and keep your feet from smelling bad.
Every single socks do?
Not normal socks, just special silver socks, like these. And there are bandages that have little tiny nanoparticles of silver in them that'll kill germs. And the thing is that if that silver gets out of the socks or the bandages and into your blood, and you get a lot of it, your skin will turn blue. Which isn't really bad for you, but it's not good for you. And it looks like it stays in the socks and it stays in the bandages, but it might also hurt you too. In other forms, in washing machines and other things. Yep. So now we're going to put all these blocks down and move on to our other experiments. Excellent.
Here's the last one.
I almost knocked myself down on my microphone.
Over there.
So now,
Here, let's just scoot it up so we can do it.
so now I've got 2 tubes that are the exact same size.
Yeah.
And I've got 2 things with the exact same amount of water. I have 2 things of Alka-Seltzer that are exactly the same amount of Alka-Seltzer, but one's a whole big tablet.
I put one in?
and the other one I mashed up into a powder.
Can I do it?
Make sure that you grind your Alka-Seltzer tablets into a really fine powder ahead of time. That's a step to do before you even start the demo.
Type it in.
You can see the powder there.
And then you put water in it?
Yep.
And then it just, can we both do?
And so if you guys could each pour on the count of 3, wait. 1, 2, 3. Pour the water in. So what do you see?
Bubbles. I see it dissolving.
Do you see a difference between the two sets of bubbles?
Yep. This is
Yeah, the one that's a powder made a lot more bubbles. Exactly. The powder one's going faster and the big chunk one is going a lot slower.
because it's big and chunky.
Because it's big and chunky, and so it's harder for the water to get to it, and it takes a lot more time.
And his is little, so it's easier.
And so when something's really small, it has a lot more outside, a lot more surface area. And if it's big, a big chunk of it, all the stuff that's in it is trapped on the inside, so
And
it takes
it's
longer.
slow.
Exactly, it goes slower.
Kids are littler and they're faster than grown-ups.
So now, that's an interesting point.
Here.
This is a potato. When you're doing the potato, it's really useful to have a container that the potato just barely fits inside. If you have a really big bucket, then you have to use a lot of iodine and getting the mixture just right so that when you dump in the potato flakes later, it actually changes color is really hard. It takes a lot of potato flakes to get the iodine to react. So a really small container is very handy.
A carved potato.
Yeah, I peeled it and it's funny shaped. Yeah. Potatoes are full of starch. This is iodine. Iodine is really dangerous. Don't drink it. Iodine is a chemical that we use to clean cuts and scrapes if we get hurt, because it'll help kill germs. It also, iodine, if it comes in contact with a starch,
That looks ugly.
yeah, so iodine is this brownish orange color.
Root beer.
Yeah, it's root beer colored. If it comes in contact with a starch, iodine,
I put it back in. A giant peeled potato grain.
iodine will turn purple. The potato iodine stuff is really useful during the demo. You can show people, and I did this before, and this is the potato blue color.
Let's wash it.
So what do you think will happen if you put the,
Potato in there.
yeah, well,
Put the potato in.
so why don't you go ahead and put the potato in.
Put the potato in there.
There you go. Excellent.
Yeah, I got this.
Looks like we need a little more iodine water around our potato.
It's Ricky. It's
So what's happening?
real. It's turning yellow. It's turning yellow and purple.
You see purple?
No.
I don't see any purple.
I see yellow.
It just looks orange still.
Yellow.
So why is it still yellow? Why didn't it turn purple? Potatoes are full of starch. Iodine and starch turns purple.
I know. I don't know. I don't know. Hello, purple.
So this potato, most of the starch is inside the potato because it's a big potato. If I take this potato powder, it's potato, but it's a bunch of little pieces of potato. And so there's a lot more starch on the outside.
Can I put it in?
No, I'm gonna put this stuff in.
Because it's going to be harder.
And the next thing after this is definitely gonna be all me, because it's the most dangerous part of all.
Is it going to be lighting the candle?
Yeah, it's gonna be fire. So,
Yeah.
is there more potato in the potato or here in my hand?
In the potato.
In the potato. But lots of little pieces. Yeah, you can feel it. It's just potato, mashed potatoes.
And I feel it.
Yeah, it's a powder. And so there's lots of surface area, lots of outside and no inside. And so when I put it in,
It's going to turn purple. It's turning purple. It's turning purple.
yeah,
Yeah, it's looking purple.
and that's totally a different color. Yeah.